It appeared without warning, a faint trace of light moving too fast, too smooth, too deliberate. Astronomers at the Atlas Observatory in Chile logged it, labeled it, and soon realized something astonishing. This object wasn't from our solar system. They called it 3I Atlas, the third confirmed visitor from beyond the stars. Since then, its path has drawn both fascination and fear, because on October 29th, it will reach its closest point to the Sun, a moment scientists call perihelion. A moment that could change everything we think we know. NASA's silence. Strange. Anomalies in its orbit, and a warning from Harvard's Avi Loeb. If you're planning a vacation, do it before the 29th. What happens when it disappears behind the Sun? Will it re-emerge as expected, or reveal something we were never meant to see? For months, the world has been quietly tracking 3I Atlas. To some, it's just a frozen relic drifting through space, another comet melting in the Sun's light. But for others, it's something else entirely. A signal, a test, maybe even a visitor that's watching us. Discovered on July 1st, 2025, 3I Atlas is moving through our solar system on a hyperbolic path, meaning it came from outside, and it will never return. It's the third interstellar object ever recorded, after Oumuamua and Borisov, but unlike them, this one comes with secrets. Its composition doesn't match anything we've seen before. Its speed defies easy explanation, and as it approaches its final turn around the Sun, even the most confident voices in astronomy are beginning to sound uncertain. What is it really? Was a comet? A probe, or something no one dares to name? It began like so many discoveries, quietly, almost accidentally. July 1st, 2025. The Atlas telescope array in Chile was scanning the southern skies, searching for asteroids that might one day threaten Earth. But among the countless points of light moving through the darkness, one trace stood out. It was faint, yes, but it was also fast, too fast. The automated software flagged it as an anomaly, and within hours, astronomers realized they were watching something that didn't belong to our solar system. They named it 3I Atlas. 3I, the third interstellar object ever recorded. Before it came Oumuamua in 2017, the cigar-shaped mystery that slipped silently past the Sun. Then 2I Borisov in 2019, a true comet, icy and unremarkable. But this one was different. Within days, observatories across the world turned their lenses toward the newcomer. What they saw only deepened the puzzle. Its brightness fluctuated in irregular pulses, not steady like a normal comet's coma, but flickering, almost rhythmic. Its spectrum revealed an unexpected chemical signature, unusually rich in carbon dioxide, yet strangely lacking in water vapor. The ratio didn't match anything in our catalogues of known comets. And its path was hyperbolic. A mathematical sign that it had not formed here and would never return. That alone would have made 3I Atlas historic. But what followed transformed it from a scientific curiosity into one of the most talked about cosmic mysteries of the decade. When astronomers calculated its orbit, they found it would pass close to the Sun at the end of October, the 29th. To be exact, before slingshotting back into interstellar space. But as data poured in from telescopes around the world, inconsistencies began to appear. Tiny, almost imperceptible deviations in speed and angle. At first they were dismissed as measurement errors, atmospheric distortion, even rounding differences between tracking systems. Yet over the weeks, those deviations persisted. By mid-August, researchers at several universities quietly admitted something unusual was happening. The object's motion wasn't fitting perfectly within predicted gravitational models. It was subtle, so subtle that many scientists refused to take the claim seriously, but it was there. That was when Dr. Avi Loeb, a theoretical astrophysicist from Harvard, entered the conversation. To the general public, he was the same voice who had once argued that Oumuamua might not have been a natural rock at all, but perhaps a fragment of alien technology, a thin, light sail-like object pushed by starlight. His ideas had divided the scientific community, but they had also made headlines worldwide. So when Loeb mentioned 3I Atlas on a podcast in early September, people listened. He said, "If you want to take a vacation, do it before October 29th, half joke, half warning." And suddenly, 3I Atlas wasn't just an astronomical event, it was a story. The internet lit up with speculation. Forums and social media threads began mapping its trajectory, dissecting Loeb's words frame by frame. Some insisted it was merely a misinterpreted comment. The others claimed it was a coded alert. A few cited NASA's relative silence as proof of a cover-up. Because while scientists had been posting daily updates through early September, the official Atlas tracking page suddenly went quiet. NASA explained that the comet was entering a region of the sky too close to the Sun for safe optical observation, a conjunction period when glare makes precise measurements almost impossible. But that didn't satisfy everyone. Why, skeptics asked, would the world's most advanced space agency simply stop releasing orbital data at the very moment the object was approaching its most critical phase? Meanwhile, ground-based observers tried to fill the gap. Amateur astronomers using solar coronagraph instruments, devices designed to block the sun's light and reveal faint nearby structures, managed to keep the object in view for a few more days. One of them, a hobbyist known online as W. Chats Boom Clouds, claimed he'd managed to reconfigure a coronagraph called CCR1 to track 3I Atlas as it skimmed the edge of visibility. His images were grainy, almost spectral, but unmistakably showed the faint outline of a developing tail. That tail was the next mystery. Normally, as comets approach the sun, heat releases water vapor and dust, forming a luminous plume. But Atlas's tail appeared composed of carbon dioxide and nickel, an unusual combination, suggesting it had formed in a region much colder, perhaps beyond any known exoplanetary system similar to ours. As the story evolved, scientists were cautious. Journalists were not. Headlines began to read, "Harvard astrophysicist warns about mysterious interstellar visitor." NASA goes silent on 3I Atlas. Object shows signs of intelligent control. Behind the sensationalism, however, there was real science and genuine unease. To the astronomers who study celestial mechanics, 3I Atlas represented both opportunity and frustration. Its brightness meant that even small telescopes could collect data, but its unusual orbit and rapid movement limited observation time. Each night brought new readings, new discrepancies, and new debates about what those numbers meant. A team in Hawaii compared Atlas's velocity before and after solar heating. Instead of the expected acceleration from outgassing, gases escaping the surface like miniature thrusters, the object seemed to decelerate slightly. The difference was minute, but it didn't fit standard models. Something was interfering with its momentum. Was it geometry, instrument error, or something else? For every scientist urging caution, there was a YouTuber or TikTok theorist ready to claim the opposite. "This is the one video declared, its thumbnail showing a glowing craft behind the sun. Another influencer described 3I Atlas as a cosmic Trojan horse, an ancient probe entering our system. Under the disguise of a comet, Avi Loeb himself walked a careful line. He never said it was artificial, only that the possibility could not be ruled out. In one interview, he compared it to what he called a Turing test by a superior intelligence, a scenario in which a civilization might send probes to see if we're intelligent enough to recognize them. That quote alone was enough to send the story viral. And with the 29th of October approaching, tension began to build. Astronomical societies announced coordinated observation nights. Forums circulated live countdowns. Some believers predicted a signal event, a deliberate transmission or course change once the object passed behind the sun. Others expected nothing more than another cold rock vanishing into darkness. Yet everyone seemed to agree on one thing. Something about 3I Atlas felt different. Part of it was timing. Humanity, after all, was watching the stars more than ever. Thousands of amateur telescopes, millions of digital eyes scanning the skies each night. If something truly extraordinary were happening out there, someone would notice. Part of it was pattern. Each interstellar object before this one had broken a rule. Oumuamua reflected sunlight in flashes no one could explain. Borisov's chemistry didn't match any local comet. And now Atlas, with its erratic flicker and inconsistent speed, seemed to continue that tradition of defying our expectations, and part of it, maybe the largest part, was fear. Not fear of invasion, not exactly. Fear of irrelevance, of realizing that the universe might already be communicating, observing, experimenting, while we're still arguing over whether to look up. By the end of September, observatories had confirmed that 3I Atlas was roughly the size of Manhattan, perhaps 1 or 2 kilometers across, with a core dense enough to survive its solar encounter. Its light curve suggested a slow rotation, completing one spin every 8 hours. The flickering that had puzzled astronomers earlier might not have been artificial at all, but sunlight reflecting off jagged terrain. Or it might have been something else, intermittent outgassing, or even periodic emission of fine particles too small to track. NASA's official statements remained measured. "No cause for alarm," one spokesperson said. "We expect standard cometary behavior." But beneath that calm language, data scientists continued to model alternative outcomes. Possible fragmentation, gravitational deflection, even a total disintegration scenario if internal pressures built up near perihelion. The more cautious voices, like Loeb's, reminded everyone that expecting the expected had often failed us before. The countdown continued. Each night, 3I Atlas crept closer to the sun, its tail lengthening, its apparent motion quickening. For amateur astronomers, it was a spectacle. For professionals, it was a puzzle. And for storytellers, journalists, and late-night theorists, it had become something else entirely. A mirror reflecting our fascination with the unknown. What if it really is just ice and dust? What if it's not? What would either answer say about us? When historians look back on 2025, they might remember the debates, the warnings, the memes, the grainy photographs. But on that first night in July, when the Atlas telescope recorded a faint streak across a cold sky, no one could have imagined how many questions it would spark, or how few answers we would have by the time it vanished again into the dark. At first, no one noticed the silence. NASA's press office had released routine updates through September, trajectory adjustments, spectrographic readings, estimated brightness curves, the usual technical language of astronomy. But by the first week of October, something changed. The public tracking page for 3I Atlas stopped refreshing. The Jet Propulsion Laboratory, normally quick to upload orbital revisions, froze its data at October 3rd. And when journalists asked why, the agency simply replied that the object had entered solar conjunction, a period when the sun's glare makes direct observation impossible. That explanation made sense. Astronomers know that when an object passes behind the sun, it becomes invisible for weeks. But to a world already on edge, NASA's sudden silence felt different. The timing, the vagueness, and the fact that private observatories were still trying and occasionally succeeding to watch it anyway. Independent researchers noticed minor discrepancies between their predicted trajectory and the last official numbers. NASA had released tiny differences in velocity, tenths of a meter per second, but in orbital mechanics, that's enough to alter a path by thousands of kilometers over time. If the agency had more recent data, why not publish it? Soon, speculation exploded. On social media, hashtags like "Where is Atlas?" and "A NASA Silence" began trending. Videos compared the situation to past events, from Oumuamua's strange acceleration in 2017 to the classified gaps in Mars data during the 1980s. The pattern was irresistible. Discovery, excitement, and then quiet. NASA's representatives gave short, careful interviews. "We continue to monitor the object with appropriate instruments," one scientist said, "but its proximity to the sun currently limits observation." To most ears, it sounded reasonable. To others, it sounded rehearsed. Meanwhile, outside the agency, a small network of astronomers refused to let the trail go cold. Among them was Dr. Helena Wright, a British astrophysicist known for her meticulous orbital modeling. She posted that her calculations, based on data from independent telescopes, showed a faint but consistent drift in the object's trajectory, just enough to question whether gravity alone could explain it. She emphasized that it wasn't proof of anything artificial, just an anomaly worth studying. But the internet heard only one word: anomaly. The next day, her post was removed after trolls flooded her comments with conspiracy theories. She deleted her account 2 days later. Still, screenshots spread across forums, fueling new rumors. NASA knows it moved. Inside the scientific community, the mood was cautious but curious. Telescopes from the European Space Agency and Japan's JAXA were still collecting data through indirect methods. measuring dust emissions and ion signatures as 3I Atlas neared its perihelion. Most results looked normal, except for one. In mid-October, a faint burst of light appeared in coronagraph images from SOHO, the Solar and Heliospheric Observatory. At first, analysts thought it was a cosmic ray hit, a random artifact. But 3 frames later, a similar burst appeared again in the exact same region of space. When adjusted for exposure, it aligned perfectly with the projected path of 3I Atlas. Coincidence? Probably. Yet it happened again 2 days later. Short flashes, each lasting less than a second, each positioned where the interstellar traveler should be. The phenomenon was small enough to be ignored in official updates, but large enough to ignite speculation. Then came the strangest development of all, the internal memo. On October 14th, a blurry document began circulating online, allegedly from NASA's Planetary Defense Coordination Office. It contained a short paragraph referencing unusual non-gravitational acceleration and advising temporary suspension of public briefings until after solar conjunction. NASA quickly dismissed it as fake. But like all good mysteries, the denial only made it spread faster. By now, YouTube channels devoted to cosmic anomalies were uploading daily countdowns to October 29th. Thumbnail images showed glowing crafts emerging from behind the sun, dramatic music swelling beneath titles like "The Day NASA Stopped Talking" and "Atlas Awakens." Each video racked up millions of views, comment sections filled with theories, alien probes, secret missions, even divine signs. The truth was simpler. People were fascinated by silence. When an agency built on communication stops speaking, imagination fills the void. Inside NASA, things were far less cinematic. Engineers at the Goddard Space Flight Center continued processing data from solar instruments. They saw what they expected, a faint, dusty coma, slowly brightening as the object neared the sun. No controlled maneuvers, no sharp turns, just physics. But they also saw something they didn't fully understand, and a narrow, concentrated jet of gas streaming from one hemisphere of the object, aligned almost perfectly with its direction of travel. It wasn't enough to alter its orbit dramatically, but enough to raise questions about how its surface was structured. If natural, it was one of the most asymmetric outgassing patterns ever recorded. If artificial, well, that was the thought no one wanted to say aloud. When journalists pressed for updates, NASA redirected them to its public FAQ page, which still displayed the same bland sentence: Comet 3I Atlas remains under observation. No unexpected activity detected. The date stamp at the bottom, October 3rd, and hadn't changed. Meanwhile, Avi Loeb kept the debate alive. He published a short article suggesting that if the object were an artificial probe, the week surrounding its perihelion would be the ideal time for a maneuver, using the sun's gravitational well to perform an Oberth effect, a theoretical slingshot that multiplies velocity while conserving energy. Most physicists dismissed the idea as science fiction, but Loeb's point was simpler. We should be watching, not assuming, and that was the irony. During the only period when observation mattered most, Earth's instruments couldn't watch at all. As the 29th approached, NASA's silence became its own kind of communication. Conspiracy channels claimed the agency had been ordered to cease all commentary. Skeptics countered that NASA simply didn't want to waste resources on a non-event. Both sides missed a deeper truth. Sometimes silence is just science waiting for data. But the public didn't see it that way. To them, NASA's quiet felt heavy, like a pause before something important. Every day without an update was another day of anticipation. Another day the unknown grew larger. Then, on October 21st, the date of solar conjunction, Atlas officially slipped behind the sun from Earth's perspective. Telescopes went dark. Radar couldn't penetrate the glare. For the first time since July, no one could see it. It was as if the object had stepped into the fire. For 8 long days, the world waited. Articles speculated about what might happen when it emerged again. Would it remain intact? Would it shatter into fragments like some comets do under solar heat? Or would it impossibly change course? NASA stayed silent. The European Space Agency released one sentence: observation will resume post-conjunction. Even Loeb went quiet, and that quiet, paradoxically became the loudest noise in science, because silence invites imagination, and imagination has no boundaries. By October 25th, even mainstream news networks had joined the chorus. Anchors used phrases like mysterious, visitor, cosmic enigma, and classified monitoring. Footage of the sun blazed on screens. Worldwide, as commentators wondered aloud, what if something waits behind that light? At a small observatory in Spain, a group of amateur astronomers prepared for the moment of reappearance. Their telescopes, custom-fitted with solar filters, were aimed just a few degrees from the sun. The air buzzed with static and expectation. If 3I Atlas followed its predicted path, it would become visible again on the evening of October 28th. If not, then no one knew what to expect. Midnight passed, then 1 o'clock. 2. The first faint streak appeared on their monitors just before dawn, not bright, but there, a whisper of light emerging from the sun's glare. Right on schedule, right where physics said it should be. The astronomers cheered, relieved and exhausted. But one of them, scrolling through the data, noticed something odd. The light curve was stronger than expected, too strong for an object that had just endured the sun's heat. It wasn't a huge difference, just a few percent, but it suggested that something about its surface had changed. Had it fragmented, reoriented, or done something else entirely? NASA's public page finally updated that morning, October 28, 2025. After 25 days of silence, the line appeared in small, neutral font. Atlas successfully observed post-conjunction. Object remains on hyperbolic trajectory. No deviation detected. To most readers, it was the end of the story. To others, it was the beginning of a bigger one, because silence, once broken, doesn't erase what it hides. It only changes the questions we ask next. When the first new images of 3I Atlas appeared after solar conjunction, relief swept through the scientific community. The object had survived its close encounter with the sun. Its orbit, according to preliminary readings, remained unchanged. No sudden maneuvers, no catastrophic fragmentation, just a traveler passing by, as expected. But the relief didn't last long. Within hours, researchers noticed something strange in the fresh data, an increase in reflectivity. The surface of 3I Atlas seemed to have brightened, almost as if it had been polished by the solar wind. For a natural comet, such a jump in albedo was unusual. It could mean new ice had been exposed after the heat stripped away dust, or, as others began to wonder, it could mean something else. And so, with the object once again visible, the conversation turned to what it might really be. The first theory was the simplest: a comet, a natural body, born in the outer reaches of another solar system. Perhaps it had wandered for millions of years through interstellar space, before gravity finally pulled it toward ours. This view fit comfortably within known physics. The odd chemistry and carbon dioxide rich. Water pore could be explained by a colder formation zone, far from any star's heat. Its brightening after perihelion might simply be the result of surface volatiles being blasted into space, revealing cleaner ice beneath. It was logical, it was predictable, it was safe, but not everyone was satisfied. The second theory, far less conventional, came from Avi Loeb and his research group at Harvard's Galileo project. They argued that 3I Atlas might not be entirely natural, not necessarily an alien ship, but possibly a technological relic, a probe, a fragment, or even a defunct mechanism ejected from another civilization's star system. Loeb reminded his readers that in 2017, Oumuamua had displayed similar oddities: no visible tail, a strange acceleration, and a thin, flattened shape. Back then, the simplest explanation had been comet too, until data no longer supported it. What if, Loeb wrote, interstellar space is filled with debris from other civilizations, the same way our oceans are littered with remnants of ships? It was a provocative idea, poetic even, and it divided the scientific world. Some called it bold curiosity, others called it professional suicide. But in the case of 3I Atlas, Loeb saw patterns that reminded him of Oumuamua: the velocity, the irregular flicker, the unexplained asymmetry in outgassing. And then came his most controversial point. If an advanced civilization wanted to send probes across galaxies, he said, the most efficient way to do it would be to use stars, not just for light or warmth, but for speed, a concept known as the Oberth maneuver. In simple terms, the Oberth effect uses a gravitational well, like that of the Sun, to multiply the energy of propulsion. If a spacecraft fires its engines at the point of deepest gravity, the energy gain is exponential. It's the ultimate cosmic slingshot. Our own spacecraft, like the Parker Solar Probe, already use mild versions of it, but to use it perfectly, to skim the surface of a star and fire engines at the exact moment of closest approach, would require precision we've barely achieved. Loeb suggested that if 3I Atlas were a probe, the days following October 29th, its perihelion, would be the most likely time for such a maneuver. That's when the object would be fastest, and when its hypothetical engines could yield the greatest effect. He didn't claim it would happen. He simply said, if it did, this is when it would. For believers, that was enough. For skeptics, it was reason to roll their eyes. A third theory emerged from within NASA itself, not publicized, but quietly shared among mission analysts. It suggested that 3I Atlas might not be alien or mysterious at all, but part of a class of objects we've only recently begun to understand, interstellar planetesimals. These are the building blocks of distant planetary systems, ejected during their violent youth. Millions of such fragments could be wandering the void at any given moment. In this view, Atlas was not unique, just newly visible. Its anomalies, chemical, orbital, photometric, could all be explained by the chaos of its origin. It was an elegant answer, grounded in science, but it lacked drama. And drama, it turned out, was what people wanted. Online, theories multiplied like constellations. Some were bizarre, others almost believable. One claimed Atlas was an ancient probe, dormant for millennia, programmed to awaken when it sensed intelligent radio signals from Earth. Another insisted it was a failed alien engine, still smoldering from a civilization long extinct. A third proposed it was not physical at all, but a gravitational anomaly, a rip in space-time created by the collision of distant stars. Each theory found its audience, each one promised revelation, and as October 29th approached, those audiences merged into something larger, a movement of expectation. The night skies had become theater. Every telescope pointed toward the sun's edge, waiting for a flicker, a pulse, a deviation, any sign that the impossible might be real. But amidst the noise, a few voices urged caution. Dr. Helena Wright, the British astrophysicist who had predicted earlier orbital drifts, reappeared online. In a public live stream, she addressed the chaos directly. "We must remember," she said, "that data gaps breed imagination. NASA's silence doesn't prove conspiracy. It proves limitation." Still, she admitted that the post-perihelion brightening was odd. Too linear, she called it, as though the object's reflection were coming from flat surfaces, not jagged terrain. That comment, flat surfaces, reignited everything. Clips of her statement spread on TikTok and YouTube within hours, twisted into headlines. "Scientist admits Atlas has flat panels, solar reflection or solar sails." By the next morning, solar sail theory was trending. To understand why that theory resonated, one has to look back to Oumuamua. Loeb had proposed that it, too, could have been a light sail, a thin, metallic sheet propelled by radiation pressure. It explained its strange acceleration without visible exhaust, and its brightness fluctuations as reflections from a flat, rotating surface. Most scientists dismissed it, but it stuck in the public imagination. Now, years later, 3I Atlas was showing similar traits. It was as if the universe had delivered a sequel no one asked for. So when observers noted the post-perihelion brightening, the connection was irresistible. If it was just sunlight bouncing off clean ice, fine, but if it wasn't, if those glints came from metal, from panels, from design, then maybe we weren't looking at a rock at all. Meanwhile, radio telescopes across the world were listening. SETI, the search for extraterrestrial intelligence, allocated time on several deep space arrays to monitor Atlas's coordinates. For weeks, they heard nothing unusual. But on the night of October 30th, a faint burst appeared in one of their recordings. A short, narrow-band spike near, 40 and 20 MHz, the hydrogen line, often considered a universal frequency for Interstellar. The communication, it lasted less than a second. Technicians quickly attributed it to interference, but that didn't stop people from connecting the dots. The next morning, online headlines screamed, "Signal detected near Atlas." Even though the report was false, the idea had already escaped into the wild. By now, the line between science and speculation had completely blurred. Astronomers gave cautious interviews, repeating the same phrases: no evidence of artificial origin, no deviation from predicted path. But the more they reassured, the less anyone believed them, because the human mind doesn't crave certainty, it craves mystery. And 3I Atlas, with its nameless origin, its silent passing, its coincidental timing, had given the world exactly that. As October turned to November, one final theory began to take hold: the observer effect. It didn't focus on aliens or physics, but on psychology. The idea that our collective attention, our global fixation, had transformed a lump of ice into something greater than itself, that we had made it mysterious by looking too hard, by expecting too much. The 3I Atlas, in the end, was less a message from the stars and more a mirror of our own longing to not be alone. Whether comet or craft, that longing had already changed us. The story had spread across every platform, every language. Billions of people had looked up, truly looked up, for the first time in years. And perhaps that, too, was a kind of contact. Facts are stubborn things. And as the theories spiraled further into speculation, scientists began returning to what could actually be measured. By early November, new data from the Hubble Space Telescope and ESA's solar orbiter offered a clearer picture of 3I Atlas, and it was both ordinary and extraordinary at once. The object had survived its brush with the sun almost perfectly, intact, no signs of fragmentation, no pieces drifting. Away, its trajectory remained cleanly hyperbolic, confirming once again that it was not bound to our solar system. But the fine details, the ones that always make or break a mystery, were what kept everyone guessing. When Hubble's images were processed, researchers noticed something subtle. The coma, that hazy cloud of gas surrounding the nucleus, was asymmetrical, bending sharply in one direction, like a flag in solar wind. Ordinary comets shed material in a diffuse halo. Atlas's outflow looked organized. A narrow collimated jet streamed from one side, aimed almost perfectly along its direction of motion. For some, this was just geology, perhaps a single active vent exposed as the sun's heat cracked the crust. For others, it looked engineered, as if the jet's alignment was deliberate, so a natural engine performing what NASA called non-gravitational acceleration. When questioned, NASA's spokesperson gave the expected answer: localized outgassing can produce vector thrust. There is no evidence suggesting artificial control. Still, the phrase vector thrust echoed across the internet like a coded admission. At the European Southern Observatory, astronomers ran simulations of the object's spin and reflectivity using the new light curves. They confirmed that 3I Atlas rotated once every 8 hours, give or take, but its brightness pattern didn't match a spherical body. It fit better with an elongated shape, roughly 700 meters long and 250 meters wide. Tumbling slowly end over end. Sound familiar? It was eerily close to Oumuamua's dimensions, the same odd, stretched silhouette that had fueled speculation years earlier. One scientist, speaking off record, reportedly said, "It's as if the universe keeps throwing us the same riddle, hoping we'll finally understand the question." Then came the spectroscopy results. The James Webb Space Telescope had caught glimpses of Atlas's chemical signature weeks before the conjunction. Analysis revealed an abundance of carbon dioxide and nickel, but virtually no water vapor. That ratio made no sense for a typical comet. Water ice is usually dominant. Nickel, on the other hand, suggested metal-rich dust, something that forms under much higher temperatures. In short, Atlas seemed both too cold and too hot to fit any known category. Born in a frozen region, yet bearing the fingerprints of fire. It shouldn't exist, and yet, there it was. The discrepancies piled up. An independent, team in Japan used polarimetric analysis to measure the orientation of light reflecting off the coma. The polarization angle remained unusually stable over several days, meaning the dust grains were aligned. Not random, natural alignment can occur under magnetic fields, but that would require a field strength thousands of times higher than expected. Some suggested that the alignment might be due to internal magnetization, a metallic core, perhaps, or something capable of generating its own field. Others argued it was merely coincidence, but again, coincidence rarely trends for weeks on end. The SETI Institute quietly released a technical note in mid-November. They confirmed that their previous signal detection near the hydrogen line had been human interference. And a satellite burst reflecting off Earth's ionosphere, no alien transmission, no message, just noise. Yet that single, sober clarification was drowned out by the far more dramatic narrative circulating online. People didn't want static, they wanted story. Back in Harvard, Avi Loeb doubled down. He published a short commentary titled, "The Absence of Proof is Not Proof of Absence." In it, he wrote, "We cannot expect interstellar technology to behave according to our engineering assumptions. If you were to drop an iPhone into the Jurassic period, the dinosaurs would likely call it a shiny rock." To Loeb, the very strangeness of 3I Atlas, the unmatching chemistry, the clean trajectory, the asymmetrical jet, was precisely what made it worth considering as artificial. To others, it was a reminder that humans see patterns even in randomness. As November progressed, observations continued. I-Atlas was now fading rapidly, drifting away from the sun, its speed exceeding 70 kilometers per second, too fast for any spacecraft we've ever built. Each day it grew dimmer, colder, more distant. Telescopes captured the last glimpses before it slipped beyond practical reach. What remained were petabytes of data and a public hungry for closure. But closure never came. The final NASA summary, released on November 30th, stated, 3I Atlas exhibited properties consistent with an active interstellar comet. No anomalous behavior conclusively observed. And that was it. No follow-up, no press conference, no explanation of the jet, the reflectivity, or the polarization mystery. Just a neat bureaucratic full stop at the end of a cosmic question mark. In the days that followed, debate shifted from what 3I Atlas was to what it meant. Scientists were divided not on data, but on philosophy. To one camp, skepticism was a duty. The scientific method itself demanded restraint. To the other, restraint had become blindness, a fear of imagination disguised as caution. Helena Wright summed it up best during a conference in Geneva. Perhaps the problem isn't that we lack evidence of other civilizations. Perhaps the problem is that we keep deciding what evidence is allowed to look like. Her words hung in the air. Not accusation, not declaration, but invitation. An invitation to wonder without losing reason. Meanwhile, outside academia, the story of 3I Atlas had already entered folklore. Podcasts called it The Visitor. News sites ran retrospectives titled The Comet That Divided Science. Even Hollywood optioned a film deal before the year was over. In the popular mind, the facts no longer mattered, only the feeling. And that feeling lingered, the thrill of looking up at the unknown and realizing it might be looking back. So what, in the end, was the evidence? That a small icy object from another star system entered ours, that it behaved in ways both familiar and strange, that its chemistry didn't match expectations, that its structure may have been too precise to be random, that it neither confirmed nor denied any theory, but hovered between them, a paradox on a cosmic scale. It left us with no proof of life beyond Earth, but it also took away the comfort of certainty. The universe had knocked on our door again. And this time it didn't bother to explain itself. The world loves countdowns. They make chaos feel measurable, the unknown feel scheduled. And as October 29th approached, the date became more than a point in space. It became a deadline. News anchors, live streamers, and amateur astronomers alike began using the same phrase, when it goes behind the sun. The moment 3I Atlas would disappear, unseen, unreachable, unmeasured. For scientists, it was simply a technical challenge. For the internet, it was an apocalypse appointment. Forums filled with predictions, some poetic, others hysterical. Would it slingshot out of our system and vanish forever? Would it slow down as if braking deliberately? Would it impossibly change direction? In chat rooms and late-night radio, the tone blurred between fascination and fear. Something ancient stirred in the human psyche, the instinct that when the heavens move strangely, the earth should tremble too. By October 28th, every observatory capable of monitoring solar proximity had its instruments locked in. The European Space Agency, NASA, even the amateur networks coordinated a global observation plan. The plan was simple: capture data until the sun's light overwhelmed the sensors. Then, wait. But as the hours ticked closer to perihelion, the numbers began to shift, not dramatically, just enough to make people lean closer to their screens. The light curve from Atlas brightened faster than expected. Within 6 hours, its intensity had doubled. Thermal models couldn't explain it. Some argued it was venting gas under extreme solar heat. Others whispered that this was the signal. The closer it got to the sun, the stranger it became. At one point, its spectral line briefly spiked at a frequency associated with ionized nickel, like metal under stress. Coincidence, said the scientists. Pattern, said everyone else. At 1642 UTC, telescopes across the globe lost visual lock. Ein Atlas had entered the blinding perimeter of the sun. For the first time since July, it was gone. In those moments, the world held its breath. Even those who didn't believe watched live streams in quiet awe. News networks filled airtime with experts debating probabilities. Social feeds turned speculative, philosophical, apocalyptic. It felt as though humanity was collectively staring at a cosmic curtain, waiting for it to open, or never open again. NASA's official broadcast ended with a single sentence: Comet 3I Atlas is now in conjunction. Observation will resume post-perihelion. That was all, no dramatics, no promises, just silence. But in that silence, imagination bloomed. Across the world, people stayed awake through the night of October 29th, watching the stars even though the object itself was invisible. Some prayed, some joked, some just stared upward, as if expecting something to blaze across the sky. Meanwhile, deep space instruments continued to listen. Solar satellites recorded bursts of radiation, coronal ejections, magnetic tremors, all normal solar behavior. And yet, within the noise, analysts noted a single anomaly, a brief, narrow dip in solar brightness lasting 0.7 seconds, too short to be meaningful, too strange to ignore. It came from the same coordinate range where Atlas should have been. A shadow, maybe a glitch probably. But to those watching the raw data feed, it felt like a heartbeat. Hours turned into days. October. Still no sighting. NASA and ESA confirmed that glare would prevent visibility until early November. But patience isn't humanity's strong suit. Conspiracy. Theorists declared that something went wrong. Some said Atlas had stopped. Others said it had vanished. Few claimed that governments were tracking a new object, entering a different trajectory. Object 3IB. None of it was verifiable, but all of it spread like wildfire. Then, on October 31st at 03:11 UTC, a small observatory in New Mexico picked up a faint glimmer emerging from the sun's west limb. It wasn't bright enough for confirmation. It flickered, then disappeared. But for a brief moment, hope and fear ignited again. By November 1st, larger telescopes began detecting it too. Atlas had survived, but not unchanged. Its magnitude readings didn't match the pre-conjunction predictions. It was brighter, almost 3 times more luminous than before. The object that went behind the sun wasn't exactly the same as the one that came out. The simplest explanation: surface exposure. The speculative one: transformation. NASA released a calm, 1-paragraph statement. Object 3I Atlas observed post-perihelion. Increased albedo likely due to resurfacing or fragmentation. No deviation from hyperbolic trajectory. But the public didn't buy. And not when the object's brightness pulsed every 47 seconds in a consistent pattern. Not when that pattern matched almost perfectly the oscillation rate of a human-made beacon. Astrophysicists cautioned against over-interpretation. Rotation, they said, Nothing more. Still, even scientists watched the graphs twice, wondering if randomness could really look that deliberate. In the background, Loeb's followers grew louder. They claimed this was the proof, the Oberth maneuver, disguised as physics, that Atlas had used the sun's gravity not to escape faster, but to slow down, to shift course, to change direction just enough to stay within the plane of our solar system a little longer. The calculations were debatable, but the imagery was irresistible. An interstellar probe diving toward a star, absorbing its light, and then veering off silent and unseen, to wherever or whatever its purpose required. It sounded like fiction, but for a few weeks in late 2025, the world wasn't sure it was. By mid-November, confirmation arrived. 3I Atlas was receding, fading, behaving mostly like a comet should. The pulse pattern weakened, then vanished. Its trajectory remained hyperbolic. Outbound toward the constellation Pegasus, it had come and gone, no lights, no message, no miracle, and yet no one felt the same. Because for that 1 month between silence and speculation, humanity had looked outward together, across cultures, languages and beliefs. Billions of eyes turned skyward, asking the same question whispered since the dawn of time: are we alone? The answer, as always, was silence, but this time it felt less empty. Still, a few anomalies lingered: the carbon-nickel ratio, the precision of the jet, the reflected brightness that refused to fit a model. All small things, buried in appendices and datasets, waiting for someone else to notice, someday. Because the universe never answers directly. It leaves clues scattered across centuries, daring us to connect them. And as 3I Atlas faded into darkness, past Mars, past Jupiter's orbit, into the cold beyond, the story didn't end. It simply changed medium from light to memory, from science to myth. The countdown was over. The object was gone. But what it left behind couldn't be measured in kilometers or magnitudes. It left a feeling, that thin line between curiosity and fear, where discovery always begins. And maybe that's what 3I Atlas really was. Not a comet, not a ship, but a question written across the sky, in a language we haven't learned to read yet. It came from nowhere. It stayed just long enough to make us look up. And then it left, silent, indifferent and unforgettable. Whether it was ice or intelligence, comet or craft, 3 Atlas forced us to face something most of us had forgotten: how little we truly know. In the end, there was no message, no revelation, just a thin streak of light, vanishing into the dark, and billions of hearts still wondering what it meant. Maybe that's the point. Maybe the universe doesn't give us answers all at once, maybe. It wants us to keep asking, because every mystery, every silence, every object that crosses our skies tells us the same thing. We are still explorers, still learning, still small beneath the stars. If you want to keep uncovering stories like this one, subscribe, share, and tell us in the comments. What do you think 3I Atlas really was?